This is a world with no safe pause. Each passing day is a continuous test, and survival always comes at a cost. A world shaped by intense pressure gradually comes into view. This is a landscape where every breath requires an exchange. Survival is bound to constant challenges and the quiet presence of predators. In this harsh arena, nothing is guaranteed. Only the uncompromising rules of nature persist. Life continues through a brutal but necessary cycle. Some individuals fall so that thousands of others can persist. This rhythm of survival, despite its severity, forms the foundation that maintains the complex balance of the wild. It has been shaped over thousands of years and keeps the entire ecosystem stable. Millions of years ago, the old Doinyo Lengai volcano released rare mineral ash rich in calcium and phosphorus. These materials settled and gradually penetrated the basalt soil over long periods of time. The persistent accumulation of minerals created nutrient-rich lands where grasses grow densely. Growth cycles are extended, and recovery after grazing occurs rapidly. Across open plains, stable food sources appear in predictable seasons. This attracts large concentrations of wildebeest that move along routes repeated across generations. These routes align closely with mineral-rich soil bands. Calcium supports bone structure. Phosphorus sustains energy exchange. Together, they allow herds to maintain physical condition during long journeys. Their continuous presence triggers a chain of ecological responses. Zebras consume the coarse upper grass layer. Gazelles access lower tender shoots. This creates natural food stratification and limits overexploitation of grasslands. Dung and hoof prints return minerals to the soil. The cycle remains closed and self-sustaining. No sudden landscape transformation is required. No obvious surface markers are needed. Mineral-rich soil, resilient grasslands, and large herds moving repeatedly in the same direction are sufficient to maintain an ecosystem shaped by distant geological history. Wildebeest hold a central role in the largest migration system in East Africa. The presence of this species determines the operating rhythm of the entire open savanna. Herd movement is not driven only by seasonal rainfall. It also follows mineral-rich soil bands formed by ancient volcanic activity. Ash from the old Doinyo Lengai volcano once covered basalt plains. This process left unusually high levels of calcium and phosphorus. Over long periods of accumulation, this substrate became the foundation for grasslands. With exceptional nutritional value. These grasslands are capable of supporting herbivore populations at very high densities. Each year, approximately 1.5 million wildebeest maintain continuous movement. The route does not expand randomly. It closes into a loop nearly 1,200 miles long. The full migration corridor covers the Serengeti Masai Mara ecosystem. The area extends over more than 11,600 square miles. The southern portion of the loop lies on the Serengeti Plains. Rain arrives earlier in this region, and grass regenerates quickly. The northern portion extends into the Masai Mara. This area retains moisture longer during dry periods. The two regions complement each other and maintain year-round food availability. The herd does not move based on impulse. Each directional shift is based on three key conditions. Young grass must contain sufficient minerals, water sources must remain continuously accessible, open space must be suitable for reproduction. When rainfall occurs in distant areas, herd structure rapidly reorients. Previously grazed plains are abandoned even when food is not fully depleted. Continuous movement reduces pressure on individual areas. Grassland quality is maintained over long timescales. The greatest risk occurs at river crossings. Here, hundreds of thousands of individuals concentrate within a short period. They are forced to cross deep water, crocodiles gather densely at narrow river sections. Loss rates increase significantly. Each migration season, approximately 77,000 pounds of biomass remain trapped in river channels. This material decomposes rapidly. Phosphorus levels in the water increase by more than 450%. Carbon increases by 191%. Nitrogen increases by 78%. The river system shifts into a nutrient-rich state. Aquatic organisms and associated food chains expand. Each step taken by wildebeest both consumes resources and contributes to landscape renewal. Their movement regulates ecological processes across East Africa. Early daylight spreads across the Ndutu Plains. Temperatures remain low. Thin mist settles close to the ground and limits visibility near the surface. Under these conditions, a group of lionesses begins to move. Spacing between individuals remains consistent. No unnecessary sound is produced. The approach direction has been determined in advance. It is based on the position of a wildebeest herd moving slowly after the night period. The herbivore herd maintains a large formation. At the outer edge, a young individual gradually falls out of sync. This slowdown creates a brief vulnerability. Two lionesses increase speed slightly and close in from separate directions. The intent is not immediate attack. The goal is to force the herd to change direction. Movement is pushed toward open terrain where escape capacity is reduced. Ahead, another individual remains low in tall grass. A blocking position is maintained. Distance is calculated to avoid early detection. When the herd begins to register danger signals, reactions occur almost simultaneously. Multiple individuals leap forward. Hooves strike the hard ground with force. Formation stability breaks down. Movement direction shifts away from the original axis. Body mass is applied to the prey. Teeth lock onto the neck region. Blood vessels and airways are compressed. Resistance declines quickly. Movement ends within a short duration. Most of the herd escapes the danger zone. One individual is retained. The hunt is complete. Spotted hyenas fully exploit the concentrated calving period of wildebeest. When hundreds of thousands of newborn calves appear within a short time, hunting pressure increases across the entire plain. Hyenas do not depend on drifting carcasses. Most daily energy comes from active hunts. The proportion of prey killed directly by hyenas ranges from 60% to 95%. This range depends on local conditions and herbivore herd density. Within dense wildebeest movement, a single hyena can detect a newly born calf. Small body size, incomplete reflexes, and low speed make calves easier to separate from the herd. The hyena moves close to the ground and approaches from behind or from the side. The moment is selected when herd movement becomes uneven. The jaws make direct contact with the rear of the body. Defensive response from the mother occurs immediately. The head lowers. Horns are directed toward the threat. Force from the push drives the predator back. The calf is quickly pressed into the center of the herd. Higher density reduces access and limits further attack. The Ngorongoro crater creates a distinct environment for spotted hyenas. The area is relatively small, but food availability remains high and stable. Within less than 15 square miles, hyena density can reach up to 470 individuals. This high concentration promotes small group hunting strategies. When a suitable target appears, three to five individuals separate from the larger group. Flexible spacing is maintained during pursuit. The strategy does not rely on short bursts of speed. Hyenas prioritize endurance. A steady running pace is maintained over distances from 1 to 3 miles. The prey is forced to sustain high speed for extended periods. Physical fatigue becomes evident during the final phase. Distance closes rapidly. The outcome typically occurs when resistance declines to a minimal level. The jaws of spotted hyenas generate bite force exceeding 992 pounds. This force is sufficient to break large bones. After a kill, the entire carcass is consumed almost completely. Meat, Bones, hooves, cartilage, and teeth are processed. Very little remains. Spotted hyenas play a critical role in removing dead biomass. Nutrients are returned to the environment. Continuous energy flow is maintained across biological levels. Each zebra carries a unique stripe pattern. No two patterns are exactly identical. This variation functions as an identification signal within large herds. Herd size can reach thousands of individuals. At close range, patterns help maintain group cohesion. At long range, when herds move together, stripes overlap. A complex visual field is formed. This reduces the ability of predators to isolate a specific target. When zebra herds move in unison, boundaries between individuals become unclear. Stripe lines shift continuously with running motion. Isolating a single individual becomes difficult. This effect is not random. It results from the interaction between pattern structure and collective movement. Recent biological studies show that polarized light reflected from stripes disrupts orientation in tsetse flies and horseflies. These parasites cause blood loss and transmit disease. As a result, zebras experience lower insect pressure than many other grazing species in the same environment. In terms of locomotion, zebras can reach speeds of up to 40 miles per hour over short distances. During large-scale migrations, the species often moves at the front of the herd. Their role extends beyond following migration flow. They directly influence grassland structure. Zebras preferentially graze older, coarse and tough grasses in the upper layer. This process exposes younger grass beneath. The newly exposed grass is more nutritious, and easier to digest. This layer quickly becomes an important food source for other herbivores. Wildebeest benefit in particular. This sequence distributes grazing pressure across layers. Grassland depletion over short periods is reduced. More than 250,000 zebras participate in the annual migration. They form a stable and organized moving mass. Spatial memory plays a critical role in this process. The hippocampal region of the zebra brain is well developed. This allows storage of information about water sources, grazing areas, and migration routes spanning hundreds of miles. As a result, herds maintain accurate routes across multiple seasons. This accuracy persists despite continuous changes in the savanna environment. Lake Ndutu formed in a strongly alkaline environment. The pH level can reach 10.5. These conditions eliminate most common aquatic organisms. Fish mollusks and many other species that cannot adapt are absent. However, mineral-rich water creates ideal conditions for microalgae growth. Spirulina is especially dominant. This microalgae reproduces rapidly. Dense layers of biomass form near the water surface. The stable presence of spirulina shapes the bird population structure at the lake. Lesser flamingos gather in large numbers to exploit this food source. In years with high rainfall, water levels rise sufficiently to expand the lake surface area. This allows breeding grounds to form. During these periods, hundreds of thousands of lesser flamingos assemble. The area becomes one of the largest concentrated breeding sites for the species in East Africa. The lesser flamingo is currently the most numerous species within the flamingo family. The total population in East Africa is estimated to exceed 2.2 million individuals. Distribution of the species is closely linked to shallow alkaline lakes. These environments support continuous microalgae growth. Diet composition remains nearly constant. It consists primarily of cyanobacteria and diatoms rich in carotenoids. These pigments gradually accumulate in body tissues. They produce the characteristic pink-orange coloration of feathers and skin. The bill structure of the lesser flamingo is optimized for filter feeding in shallow water. The downward curved bill contains more than 10,000 fine filtering plates. These plates are densely and evenly arranged. During feeding, the head is inverted at the water surface. Water is drawn in and expelled continuously. Filtration rates can reach up to 20 cycles per second. This allows efficient separation of microalgae from water. The process continues almost without interruption for many hours. The combination of alkaline lakes, abundant microalgae, and specialized feeding structures forms a closed system. Lesser flamingos depend entirely on this environment to maintain large populations. Any change in water level or lake chemical composition directly affects survival and reproduction of the population. Large footprints press deeply into cracked, dry ground. African bush elephants enter open space with exceptional size. This species is the largest living terrestrial mammal. An adult male can reach nearly 13 feet at the shoulder. Body mass can exceed 15,000 pounds. At this size, very few predators attempt approach. Even Nile crocodiles avoid direct confrontation with adult elephants in shallow water. Elephant body structure is optimized for harsh tropical conditions. Large ears move continuously and release excess heat. Dense networks of blood vessels within the ears carry warm blood to the skin surface. Cooling occurs before blood returns to the body. Thick skin provides protection from insects and sunlight. Effective thermal regulation is maintained. The trunk is the most critical body component. More than 40,000 independent muscle bundles enable complex actions. The trunk is used to pull grass. Branches are collected. Water is drawn and sprayed. Mud is applied, soil is excavated, signals are transmitted within the herd. No other body part performs such a wide range of functions. When elephant herds approach the Grumeti River, movement slows. Adult individuals pause and observe before entering the water. Current strength, depth, and potential threats are carefully assessed. Calves are kept at the center of the formation. Larger individuals surround them. This formation is maintained throughout hazardous stages. Travel direction and timing are determined by the lead female. This individual possesses exceptional long-term memory. Information about water sources, feeding areas, and safe routes is retained across multiple extended dry seasons. As a result, herds access resources under severe conditions. Elephants have very high biological requirements. An adult individual requires up to 330 pounds of vegetation each day. Daily water demand exceeds 50 gallons. When surface water is depleted, tusks are used to dig shallow wells. Access to underground water pockets beneath sand is created. This water source is not used only by elephants. Many other species benefit afterward. Tusks serve a survival function. They also make elephants targets for poaching. Despite heavy pressure, Elephants maintain a keystone position within ecosystems. Elephant dung is nutrient-rich. Undigested seeds are present. These materials are dispersed over long distances. New vegetation forms along movement routes. Forest and savanna structure is maintained across many generations. After leaving the river channel, the wildebeest herd rapidly reforms its structure and continues the journey across open plains. Ahead, another threat is already present. African wild dogs appear dispersed along the migration route rather than concentrated into a single mass. A mottled coat with patches of black, white, yellow, and brown creates a unique pattern for each individual. No two individuals are completely identical. These color patches serve as identification markers. They also break up body outlines during movement. At long distances, tracking a specific target becomes more difficult. The body structure of the African wild dog is optimized for long-distance pursuit. The hunt does not begin with a sprint. A small group separates from the main pack. Distance is maintained to avoid early panic. Target selection occurs quickly. The chosen individual is often out of rhythm or positioned at the edge of the formation. When signs of fatigue appear, pace changes abruptly. A slip, a stumble, or a brief slowdown triggers the final phase. Speed increases rapidly. Velocity can exceed 37 miles per hour. Distance closes within a short time. Approach angles are adjusted dynamically. Escape routes are sealed. According to data from the Wildlife Conservation Society, African wild dogs achieve a hunting success rate between 70 and 90%. This is the highest rate among large carnivores. Efficiency does not depend on individual strength. The determining factors are tight coordination. Clear role division is maintained. Continuous pressure is applied until the prey no longer has sufficient endurance to escape the encirclement. The Marabou stalk holds a distinct position in biomass processing across the African savanna. The name grave digger bird does not originate from random behavior. It accurately reflects ecological function. The head and neck are nearly featherless. Skin surfaces are thick and dry. Direct contact with decomposing carcasses occurs without retaining fluids or bacteria. This structure reduces the risk of pathogen exposure during feeding. In terms of size, the Marabou stork ranks among the largest terrestrial flying birds in Africa. An adult can stand nearly 5 feet tall. Wingspan can exceed 10 feet. Large lift surface area is generated during flight. Despite large size, body mass remains relatively low. Hollow bones significantly reduce overall weight. Thermal air currents are used for soaring. Flight can occur at altitudes above 14,700 feet with low energy expenditure. Marabou storks rarely appear alone at large carcass sites. They are commonly present with vultures and other scavenging species. Approach sequence follows clear layering. Vultures use sharp beaks and flexible necks to tear open thick outer skin. Once the body cavity is exposed, Marabou storks advance. A large, heavy and powerful beak is used. Deep internal tissue is pulled and extracted. Other species have difficulty accessing these areas. This division increases carcass processing speed. Large biomass does not remain on the ground for long. Decomposition time is significantly shortened. Pathogenic bacteria lack conditions for widespread dispersal. Scavenging species, including Marabou storks, remove potential sources of infection before surrounding ecosystems are affected. Long-range movement allows Marabou storks to cover wide activity areas. From high altitude, Concentrations of vultures or newly formed carcasses are easily detected. Extended soaring requires minimal wing flapping. Search duration during the day is maintained. Upon landing, tall body height and long reach enable access to food even within dense crowds. Marabou storks do not participate in active hunting. The role of the species occurs at the final processing stage. Carcasses are removed rapidly. Material cycles are closed. Energy and nutrients are redistributed. Environmental overload from decomposing biomass is prevented. Leopards operate alone. They do not form groups. They leave no obvious signs. Presence is rarely detected without movement. Survival strategy does not rely on numbers or overwhelming force. It relies entirely on remaining unseen. All actions are directed toward a single objective. Detection is avoided. Body structure is compact and dense. Overall, mass is moderate, muscle density is high, power is concentrated into short, precise actions. Coat patterns consist of uneven rosettes. Body outline is disrupted when motionless. In open woodland, low brush or rocky terrain, fragmented light dissolves visible form into background. Camouflage is most effective when the leopard remains still. Leopards avoid direct confrontation. Territory is not controlled through conflict. Hunting success depends on undetected approach. Extended observation occurs prior to attack. Wind direction, concealment, position, and escape routes are assessed in advance. When distance becomes sufficient, the final strike is rapid and decisive. One of the most notable abilities is prey handling above ground. Leopards can drag carcasses heavier than their own body mass into trees or large branches. This behavior protects food from interference by other predators. Prey remains beyond reach of lions and hyenas. Loss risk after a successful hunt is reduced. Climbing and tree control ability arise from specialized anatomy. Rear ankle joints rotate through a wide range. Foot placement can grip bark in reversed orientation. Rapid ascent is enabled. Head-first descent occurs while balance is maintained. At elevated positions, leopards rest, feed, and observe surroundings in relative safety. Trees function as more than food storage. They serve as concealment and escape routes. Most feeding time occurs above ground, where interference is limited. Females reproduce and raise offspring alone. Cubs are concealed within rock crevices, dense vegetation, or hard-to-access locations. Survival rates remain low due to pressure from competing predators. Among African large cats, leopards demonstrate the broadest adaptability. They inhabit open savannas, dense forests, rocky mountains, and areas near human presence. Habitat range overlaps with multiple predator species. Avoidance, concealment, and flexibility become decisive factors for long-term persistence. As the sun drops below the horizon, savannah activity slows. After pursuits and sudden ambushes, distance between life and death is measured in moments. Conditions become temporarily quiet. Across the savannah, survival requires constant trade-offs. No species is guaranteed safety. Some individuals fall, others continue moving to locate food and water. This balance has formed over thousands of years. Ecosystem structure and food chains are maintained. When dawn appears, light initiates a new cycle. Animals become active. Hunting, migration, and resource search resume. The survival cycle continues. Landscape form and ecological balance are maintained across the wild.